All right, this is lesson 212, recognizing linear equations. Um, so a couple forms that we've seen that we know are linear are this form, which is the slope-intercept form, and this form, which is standard form. We know that equations written in those forms are linear because we've seen it. But check this equation out. Y equals the quantity 4x plus 2 times quantity 3 plus x minus 2, all divided by 2. How can we determine whether this equation is linear? Explain your reasoning. If we knew that that values that make this equation true go up at a constant rate, then we would know it's linear. So if I could do a few x values for this and find the corresponding y value, like say x is 0, x is 1, x is 2, if I could do that and I could see that it goes up by the same amount between these points, then I would know that those 3 points are collinear and that it is indeed a linear equation. I could also find the slope and the y-intercept and write it in slope-intercept form. So I'm going to do that. So I'm going to substitute 0 for x in this equation and find y. So instead of 4 times x, I'm going to do 4 times 0 plus. What I'm doing is I'm just substituting 0 in wherever you see an x, and then I'm evaluating the expression, figure out what y is. So 4 times 0 plus 2 times 3 plus 0 minus 2 divided by 2, and 4 times 0 is 0, 3 plus 0 is 3, and that's equal to 0 plus 6 minus 2 divided by 2, and 6 minus 2 is 4 plus 0 is 4 divided by 2 is 2. So not only do I know that y value when x is 0 is 2, but I also now know the y-intercept if this does turn out to be collinear or a linear equation. So now I'm going to substitute x is equal to 1 into the equation, so I'm going to do 4 times 1, put a 1 there, so y is equal to 4 times 1 plus 2 times the quantity 3 plus 1 minus 2 divided by 2, and 4 times 1 is 4, 3 plus 1 is 4, times 2 is 8, minus 2, that's 4 plus 8 is 12, minus 2 is 10, divided by 2 is 5. And there's actually quite a bit of work involved in doing this, and I'm just thinking that as long as this equation is solved for y, I can use technology to help me out here. I'm going to enter that equation into my graphing calculator. And if I do that, then it'll produce a table for me, so I can find the y values of these corresponding x values by doing that. So now to make sure that the whole numerator is all divided by 0, I'm going to use parentheses, and then I need 4x plus 2 times quantity 3 plus x minus 2. So 4 times x plus 2 times quantity 3 plus x, go with minus 2. Hard about doing it. Then I have to close off the parentheses that represents the other side of the numerator, divide the whole thing by 2. Just want to go back and check and make sure I did that right. So I think I got it right. Now that that equation's in there, I can go to my table and I have all kinds of x values. When x is 0, y is 2. When x is 1, y is 5. When x is 2, y is 8. And notice these keep going up at a constant rate of 3, plus 3, plus 3, when x goes up by 1. So the slope is 3 divided by 1, and it is indeed linear, since the table's going up at a constant rate. So, that was 8. So I now know this thing is linear, and I can write it in this form. Slope-intercept form. So if we can come up with a few values, we can figure out whether or not it's linear. Now, there's one other way you could tell if it's linear, and that is if you could just simplify this equation as much as you possibly can. And in 7th grade math, you learned some ways to simplify. And I'll go through that here with you. But if we could simplify it and it turned into an equation in slope-intercept form like this, where we could see the slope of the y-intercept, we would know it's linear that way. So I'm going to do that on a different page. Copy that. Make a new page. There it is. All right, so just simplifying. One thing you learned last year was about a distributive property. And if you have 2 times the quantity 3 plus x, all you do is distribute that 2 by multiplying. So you do 2 times 3 is 6, and 2 times x minus 2 divided by 2. This will get simpler. We will combine like terms. Like terms means they have the same exact variable. And if that's true, then I have x 4 times right here, and I have x 2 times here, and together I can make that x 6 times. And then I have plus 6 minus 2, that's the same as plus 4. I can divide that by 2. And 6 divided by 2 is 3x, and 4 divided by 2 is 2. And so now I can see it's written in this form, slope-intercept form, where m is 3 and b is 2. So that's another way of telling whether or not it's in slope-intercept form. So that's what we're going to do in lesson 212. All right, so if you can write an equation in that form, you know it's linear. As you recall, y equals mx plus b is often called the slope-intercept form of a linear equation. So, so we're going to try and figure out which of these are linear. And I think what I'll do is I'll do a couple for you, and then in class we'll do the rest of them. But we're going to use the method where we try and change it into slope-intercept form. All right, so I'm just going to pick a couple of these. I think what I'll do is put this on a new page, and we'll work with them one at a time. So let's do number 1. We have 3 times y is equal to x divided by 2 minus 8. All right, right now it's not really in slope-intercept form. This is slope-intercept form. So I just need something times x plus something equal y. And one thing I notice right away is I don't have y, I have 3 times y. Another thing I notice here, I have x divided by 2. I'm going to fix that x divided by 2. Dividing by 2, you may recall, is the same as multiplying by a half. So that's really the same as 1/2 x minus 8. And now to isolate this y, I have to think of a way to get rid of that 3 without getting rid of the y. Like some of you might think subtract 3y, but if I do that, then I get 0, and the y is gone. I don't want that. I really want 1y. And the way we get 1y is dividing by 3, because 3 divided by 3 is 1y. But as you recall from learning about the properties of equality, if you divide one side of an equation by 3, then you have to divide the other side of the equation by 3. All right, and so we have 1/2 divided by 3. 1/2 divided by 3 is 1/6 x, and 8 divided by 3 is 2.6 repeating, but since it's a repeating number, I'm just going to leave it as a fraction, 8/3. If you want, you can change that. If you like the mixed numbers better, that's the same as 2 and 2/3, or 2.6 repeating. So there it is. That is definitely linear because the slope is 1/6. The y-intercept is negative 2 and 2/3. All right, let's pick another one to do. Number 5 is similar to that, where we need to divide both sides by 2 to get the answer. But number 5, we also need to use the distributive property to simplify that side. Let's do that one next. Actually, let's just go right down the line. Maybe I'll do a couple. Right here, number 2, y equals 3. Is there a way you could write that in this form? In other words, is there something times x that can represent the fact that there is nothing times x right now? And actually there is. We could just represent it as 0 times x plus 3, because 0 times x is the same as 0, and 0 plus 3 is the same as 3. So that's the same equation. So yes, that is linear. So maybe I'll put an L. We found out this is linear, and we found out the slope is 1/6, and the y-intercept is negative 8/3, or negative 2 and 2/6. So yes, this one is linear. L for linear, and the slope is 0, and the y-intercept is 3. Okay. What about number 3? Y equals 2 divided by x. Now, if we're thinking about what the slope of that might be, you might think of it as 2 times 1 over x, but we're really dividing by x here, and we need to be multiplying by x to fit this form. All right, and so it doesn't seem to fit that form, but let's just check that on our graphic calculator, and just see what that looks like on the graphic. That would be kind of interesting. But we don't think it fits that form because it's dividing by x. But we're not sure. We may decide against it. And obviously that is not linear. The graph really curves. It's like that. So it's not linear. And in fact, if we look at the values in the table, you'll notice that they definitely don't follow a pattern. 2, 1, it's subtracting 1, then it's subtracting 1/3, then it's subtracting like 1/6 maybe, then it's subtracting 1/10. So it just keeps on changing. It's not linear at all. It does not go by a constant rate. So we know that number 3 is not linear. Number 4, I'm going to guess it is, just because that one kind of looks like standard form. But let's make sure by changing that into slope-intercept form if we can. I need to pause the video here because I'm running out of time, so we'll continue with part 2.